Hello everyone, welcome to my chemistry channel BL Das Short and Sweet in Chemistry. Already I have explained the hybridization in methane. Methane is a saturated hydrocarbon where sp3 hybridization takes place. It contains only single bond. Whenever you will see the methane has four bonds. Here this is methane. Now when we see the four bonds are equal in length and equivalent in energy, from that here the idea came hybridization, because here one is S a 2s and 1s overlapping and other three are 2sp overlapping. That means it is not possible, because actually practically all bonds are equal in length and equivalent in energy. That is why here hybridization came. Already I have explained in part 1. Whenever you want to read the structure of methane, please read the hybridization in methane. In methane, sp3 hybridization takes place. You know, sp3 hybridization means tetrahedral structure. Actually, sp3 hybridization, this is the one. How can you write like this? You can write like this. Clear? Now here this is the tetrahedral structure sp3 hybridization in the carbon of methane, where each contain one electron. Now whenever the hydrogen comes and close to each other, and you know hydrogen 1s orbital having one electron, they overlap like this. They overlap like this and form that hydrogen and carbon. This is the carbon hydrogen, the bond that it takes place. This is called sp3 of carbon and s of hydrogen, that overlapping takes place. So this is the case here. If you want to say this one here, this is sp3s, 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 here also sp3s. That means you can see this is the structure of methane. And how can you know the shape? What is the design? What is the shape of the this methane? Then come to here, since it is tetrahedral structure, then you can write the diagram of it tetrahedral, where in the middle center the carbon is there, and at the each corner hydrogen. So hydrogen how many? 1, 2, 3, 4. So it is tetrahedral structure. When you will see correctly, you can find this is one face of tetrahedron. See, this is the face like this. I want to draw here like this. This face of tetrahedron like this, where 3 hydrogens are there. Similarly, this side also one tetrahedron, where in center that is carbon, but here 1, 2, 3, 3 hydrogens are there. Similarly, here also tetrahedron. That means here you can say how tetrahedron face, the face of the tetrahedron looks like a equilateral triangle. That means here we can say this is tetrahedral structure and every face is equilateral triangle. Then after tetrahedral structure, when you see what is the shape and size and structure in 3D in a space, what is space arrangement? If it is a space, undergo space arrangement, what is that? Whether 3D or 2D. First we will come to 3D structure, 3D arrangement. Now this is called 3D arrangement. Now that is space arrangement, where you can see 1, 2 are simply line structure to the hydrogen. Carbon is connected to hydrogen, and whereas One is, this is a solid wedge. Solid wedge, you can write also here solid wedge. Solid wedge where it indicates a thick dot, thick line, thick black line here, solid line here, and other one is dash dash dash, DSS, dash line. So here it is called dash line, it is called solid wedge line, it is called simple line, simple line. This is simple and simple line. Then what it indicates? It indicates different type of lines, different types of bonds are there. Solid waste, the solid waste that is which is present in the plane of the paper, we can see it is towards observer. When I want to see, I can fill in a space the arrangement like this. When here this side, this one dash one, it indicates that it is away from the observer. This is towards observer, this is away from the observer. See, if the bond like this, then towards observer. If the bond like this, then away from the observer. If away from the observer, that is dash like structure. If towards observer, then it is dash solid wedge structure. Sorry, it is solid wedge structure that is towards observer. It is a dash structure that is away from the observer. You should remember, and this plane, simple line that is on the plane of the paper. Simple line indicates on the plane of the paper, and this is 3D structure. And here other structure also there, that one simple 2D structure, graphic structure. I will come to the point, and individually also I will come to the point one by one, how the solid wedge and dash structure is there, and 2D structure. This is called 3D structure, and next one we will see 2D structure, or it is called graphic picture. Now we can see the formula of methane CH4. What is the general formula? This is alkane. So what is the general formula? CnH2n plus 2. That means alkane, saturated hydrocarbon, where it contains single bond. And now here is in formula CH4, what is the main here? Main atom carbon. Carbon atom number is 6. So you can say ground state. Here the outer shell is responsible for the bonding, 2s2, 2p2. Now since it is 2p2, 1px1, py1. Now again you come to excited state, because the carbon is not a divalent, it is a tetravalent. That is why here this lower energy should jump to here, pz. So how many unpaired electrons now? 4 unpaired electrons. 4 unpaired electrons mean it can form 4 bonds. But question here you can see 2s, the lower energy level, px, py, pz having same energy level. Now 2s of carbon overlap with 1s of hydrogen, whereas px and py, pz of the carbon overlaps with 1s of hydrogen. Automatically this bond which will form with 2s, that is lower energy. But actually it is not found. Experimentally it is proved that 4 energy levels, 4 bonds are having same energy level, equivalent length, then equivalent energy. Then how it is possible? Then again it is thought about hybridization. Hybridization means the combination of the atomic orbitals having different energy and redistributed equally, equivalently in different energy level, energy orbitals, that is called sp3 orbital, and the phenomenon is called sp3 hybridization. So this is sp3 hybridization here occurs, where 1s orbital, 3 p orbitals are used. So and each orbital is called sp3 hybrid orbital. You can see here, this is one orbital, this is 1 2 3 4 1, 2, 3, 4. 4 sp3 hybrid orbitals are there, so that they have equal energy, equivalent energy, and that is here the orbital that bond which is formed that have equal length. So here this one overlaps with the hydrogen. This one overlaps with hydrogen, where hydrogen contain 1s orbital. So 1s orbital of hydrogen, and this one sp3 orbital of carbon. This is carbon, this is carbon. Here you can mention is carbon, and each one having hydrogen here. So this is tetrahedral structure, where you can find the face is tetrahedron, where it is looks like and it is also equilateral angle triangle. And so here see you can find 1, 2, 3. This is one face, this is one face. So you can find the faces of tetrahedron where it is equilateral and triangle. Now if it is a solid weight, according to the tetrahedral structure, it is 3D structure where it is arranged in a space. And now the solid wedge, that means solid structure which is there, the solid bond which is there, that is towards our observer, and that one, the dash one, which is away from the observer. Let us here, this is a towards observer, the solid, away from observer, that is dash one, and these two are simple line. Now this is called 3D structure, which is very very important in our chemistry knowledge, chemistry example. And here solid with the structure, and next is graphic peak. What is mean graphic peak? Here actually when you see, it looks like 90-degree. It looks like 90-degree here, here also, and here it looks like 90. Actually since it is a graphic peak, it is only, sorry, it is not 3D, it is only 2D. It is only 2D, and it is 90-degree, but it is not possible at all. Actually it looks like 90-degree, it behave, and the picture looks that is 90-degree, but actually it is not 90-degree. It is 109-degree 28 minutes. So 109-degree 28 minutes, and that is here 90-degree, which is not possible, which is not correct one, and that is what is called graphic peak. And also it is called 2D, two dimensional. It is 3-dimensional, that is in space, and 2D dimensional, where the angle is 90-degree. Only it indicates graphic picture, but actually it is not existing. And so this is the structure of methane. I hope it is clear, the structure of methane, and also the hybridization of methane, ethane, ethene, ethyne. I hope it is clear. And now here we can proceed to different type of conformation of alkane in coming video. I hope it is clear, and hope you will subscribe my channel BL Das, short and sweet in chemistry. And thanks again for watching my video. Thank you all.